Hi guys, so welcome to the Artist Server, and in today's video I'm going to show you a trick to visualize sensor data in a command line environment. So I used to work on Linux servers and Sun Solaris servers and a bunch of other Unix type of server operating systems, and one of the drawbacks in those type of environments is that oftentimes there's no graphical environment installed. So unlike in Windows Server or other operating systems where there's a graphical environment where you can launch an app that will show you a neat graph of the temperatures of your CPUs or your whatever other sensors you have on the system. You don't really have that in a Linux environment when there's no graphical environment installed. Now, of course, you could always extract the data out of that server and put it in a monitoring system that then plots that data out for you or puts it into a graph for you. And there are a lot of those type of solutions. But sometimes you're working on a server and you just want to observe one of the sensors because maybe you're a developer and your latest app change uses a lot of CPU resource, and you're kind of wondering, well, is it going to cause a problem with that server, and you want to kind of do some testing or just generally observe some sensor values. And you can look at the sensor values, that's not a problem, but oftentimes for humans it's easier to look at a graph than to look at just numbers. So anyway, that's kind of a challenge in a non-graphical environment where all you have is your SSH shell or the terminal basically, and all you've got is text, right? And so I figured out a way a few years ago on how to kind of, I guess it's a little bit of a trick to work around visualizing data in a terminal environment, right? Okay, so anyway, I'm logged in. Let's just get right to it. I'm logged into one of my servers here, and of course on the Linux server you can always look at the sensor data by running the command sensors, right? And so in this case you can see that I have two sockets, and this is a dual socket server, and each of those has, what is this, 5, 6, 7, 8, 9, 10 cores, and then I have the package temperature as well. So I've got sensors that are telling me the temperatures of each core on the server as well as the socket package temperature, okay? And so let's say I want to monitor this, right? So if you're just looking at numbers, you could basically run watch-n1, so that'll refresh it every second, and just run sensors. Okay, so this will just refresh that display of the sensor values once every second, and you'll see the clock here ticking away, and so that's a sign that it's refreshing every second here, and you'll see that the values change here and there. Now this is fine if you just want to look at raw values. But again, like I said, sometimes it's nice to be able to see a graph, right? So, okay, well, how do you do that in a how do you show a graph in a non-graphical environment, right? Okay, so what we need to do is extract a data stream out of those sensors. So I'm going to show you first of all kind of the manual way, because that'll kind of give you the idea of how this method works. But at the end of the video, I'm going to show you a tool that I put together. I'm going to share with you guys on GitHub that makes it a lot easier to do this, okay? But I want to show you the concept behind it so that way if you wanted to customize it for whatever it is you're doing, you will have an idea of how to do that instead of just running someone's script that, might do some of the things you want to do but might not do everything, right? Okay, so if you run sensors with -u, it'll show you a lot of the raw values and the different chips. So just as an example, this is showing me that this chip has these sensors, and so here's the physical package temperature, and the temperature input is the sensor called temp1_input, and then these other values are just kind of the thresholds. And then you have core 0 has temp2_input, and so let's monitor one of these temperature sensors. Let's look at the package temperature. Okay, so that's under this core temp ISA 000, and the sensor is temp1 input. So I can look at that specific sensor by doing core temp ISA 000, and let's see. So if I just run this, okay, so this will just show me the temperature sensors for that chip, right? So this particular CPU socket. So I want to just look at temp1 underscore input. So, and you'll notice that within the chip, all these temp sensors are uniquely numbered, and so that's really important to keep in mind if you want to extract a particular sensor value. So, well, I'm just going to do some basic Unix command line techniques to extract that number. So I'm going to use awk, and I'm going to look for a value that is temp1 underscore input colon. Okay, that's the sensor I want to extract, and once I see that, I'll print out the value, the second value, which is the actual temperature. So I believe this should give me, yep. So here, this command will basically extract that temperature reading for me. And so if I run this command over and over and over and over, I will basically be able to continue monitoring that value. Now, let's actually put that value in a file. So let me make sure I don't have any files. So yeah, I already have a file here. So I'm going to go ahead and delete that. So I'm going to start fresh. Okay. So sensor-data.log. I'm going to append that value repeatedly, once every second, to this file sensor.log. Okay. And so in order to run this repeatedly, I'll run it in a while loop. So while true. So that'll just keep running forever until I hit Control-C to break out of it. I'm going to do this command, and instead of running it just out of control, I'm going to take a pause for 1 second every time I run it. So basically, I will have 1 second resolution on the data stream. So what I'm doing really here is converting that sensor data into a data stream that I'm going to put in this sensor-data.log file, and just to give a little bit of visual confirmation that something is actually happening, I'm going to echo a period for every time it does this. And that way, at least on the screen, I can see these dots kind of flying by, and that tell me that it's still collecting data into this file. Alright, so let's go ahead and do this. Alright, so you see the periods are being printed once every second, and that means every time a period is printed, a snapshot of that sensor data is being appended to that sensor-data.log file. Let's confirm that. Let's take a look at that file. So I'm going to run tail on that file, tail-f. We'll continue watching that file, and let's just observe the data stream. Okay, so yep, it's definitely once a second, it's adding that sensor data into that file for us. Okay, so now we have a stream of data that is what we want to monitor, but again, we're still looking at raw values. We haven't really visualized this, right? So let's see, how can we visualize this? So I'm going to use a tool called GNUplot, and GNUplot is basically a graphing or plotting tool, and by default it gives you like a graphical file that you can open up in a graphic file viewer. But there is a mode that allows it to generate the graph in ASCII art, and that way you can actually see it in a command line environment. So I'm going to go ahead and do that. So what we're going to do is we're going to look at the last 120 values in that data stream. Okay, so I'll do dash, or you know what, let's make it small. Let's just do 60. So the last minute of that data stream. So we'll look at the last 60 values, and remember the values are being generated every second. So that's basically the last minute of the sensor-data.log file. So this will give me, the 60 points of data. And we're going to use GNUplot to graph that data for us. So the key to making this graph, or create a graph in ASCII art so that you can actually see it in a terminal, is when you do set terminal dumb, and that will make sure that the output is in the ASCII format or the ASCII art format. Now, one thing I'd like to do is set the size. So let me clear this for a second. Let's look at the size of this terminal. So the size is 47 by 100, or actually that's kind of reverse. It's 100 by 47. So I'm going to do 100, comma 47, and so that will set the size of the plot. And we're going to set the Y range, and I'm doing this because I've done this before, and I know usually the Y range, by default, GNU plot will set the upper limit of the Y range to basically kind of the highest value that it sees in the data stream, and that's usually just a little harder to look at. I like to give it a little bit of kind of margin there, or a little bit of space above the highest value. So this is hovering around 30, so I'm going to guess maybe if I do like 50 as the top of the range, that'll probably be okay. And then I think, then we just do a plot of standard in. Okay, so that dash means read the data from standard in because we are piping it from tail. And what else do we need to do? Oh, with lines. So that'll just make the plot, instead of just discrete data points, it will try to connect the dots. All right, so let's actually try running this and see if it gives us the desired result. Oops, let's see. Set Y range, it did not like something that I inputted. Oh, I see. Yeah, this is not a dot, it's separated by a colon. Okay, so let's try this again. Alright, so there you have a graphical, or a graph displayed as ASCII art in your terminal, right? And now that's just one snapshot of the last 60 seconds. So what if we want to see this constantly updated, right? So we can run this command in a while loop as well. So we'll do while true, do this command, and again we don't want to just run this out of control, so we're going to take a little break and sleep for 1 second, and then we'll run it again. And so this will constantly refresh the terminal with a plot of the incoming data. Alright, so now you can see that the data is moving, and that's because it's constantly refreshing, and we're seeing basically the last 60 seconds of data. Now it's pretty much flat because we're really not doing anything here. So let's make it a little bit more interesting. I'm going to background, I'm going to break the data stream that we're building here, and I'm going to do this in the background. So I'm going to remove the echo of the period so we don't have to see anything, and run this in the background. Okay, and so as you see, as soon as I started creating that data stream, or running that data stream, this graph starts refreshing, and you can see movement in it, right? Alright, so let's make this a little bit more interesting by running a benchmark. So this server, I think, has 40 threads, and let's run it for 60 seconds. We'll run a CPU benchmark, and that should warm up the processors for us, and so you're going to see the temperatures of the package temperature rise a little bit. Oops, invalid, oh, maybe it's threads. Alright, there we go. So now we are running the benchmark, and you can see that the graph is getting larger, or the temperatures are getting higher. So it's hitting about 40 degrees right now, where previously I think it was like 33 or something like that. And that looks like it's going a little bit above 40 degrees here and there. Okay, and so let me stop the benchmark, and you'll see that the temperatures come back down. Okay, so so that's how you can basically visualize data even in a non-graphical environment in a command line world. Okay, so I thought I want to share that with you guys. Hopefully you might find it useful sometime when you're working on a server where there's no graphical environment, and you would like to be able to visualize some data. Basically, right now I'm plotting the data stream from running sensors, but you could really do this with anything. Basically create a data stream into a file, and then give that data to GNU plot to generate this graph. Okay, so with that said, in case you want to just look at sensor data, I actually put together a little script that makes this a lot easier and has little extra features that might make things a little better for you. So I'll leave the link to this GitHub project in the description for you, but basically it's something I wrote that called Sensors Plotter, and you'll see here it's basically a Corn shell script that you can run in a Linux environment and probably other Unix environments as well. There's really not too much that's like Linux specific other than maybe sensors, but I think that's available on other Unix systems as well. I'm not really sure, but anyway, I developed this in the Linux environment with Corn shell. If you try this in a different Unix type of environment and it doesn't work, let me know, and I can make it better. And but anyway, so I'll leave a link to this project for you, but let me show you how this project works. Alright, so let me put this away. And so here are two other terminals, and I'm showing you two terminals here because I'm going to show you two different graphs. Okay, so this tool, if you run --help, it'll show you all the different options. And let's say we want to monitor the core temp again on the first socket, and I want to monitor the sensor temp1 input, and so that's the package temperature. And there are other options here like the width of the plot. So by default this script will show you the last 2 minutes or 120 seconds of data. You can change that by giving it dash width, but I think 120 seconds is probably fine here. And you can specify a title. So if you're monitoring more than one, if you're graphing more than one sensor data, you might want to put a label on it so that when you're looking at it, you clearly know which sensor you're looking at, right? So I can give this a title, if I can spell that right. Okay, oops. Okay, -- title equals. Okay, so this is going to be CPU1 temperature. Okay, and if you do a dash stats, it will generate some very basic statistics like the last value, the maximum value observed, the minimum value observed, and then the average. Okay, and so now if I run this, all right, so this is starting to collect data from scratch. So you'll notice that the X range is changing because as it's seeing more and more data. And so you can see at the top there's a title. It tells you this is the graph for temperature 1. And by the way, when you run this script, it's doing everything what I just showed you manually, but it's kind of automating it for you. So it makes it really easy. You don't have to separately create a data stream and then run GNU plot. It basically does all that for you. And so as we let this run, it's going to collect more and more data, and it's going to plot this out. And then you'll see at the bottom, it's showing you what the last value was 33 degrees, the max observed so far was 35, the minimum so far was 32, and the average value is 33.02, or well, it's changing as it's seeing more data. All right, so we're also going to monitor the second socket. And so I'll run this as core temp ISA 0001. Okay, so that's the second socket, and we're going to look at the sensor, same sensor, temp1 underscore input, and yes, we're going to generate some statistics, also a title. We're going to call this CPU2 temperature. Okay, so let me run that. Okay, so this is just starting to collect data, and you see it's only got 6 seconds worth of data, or 7, 8, as we let this run. So let me let this run for a little bit and allow it to collect more data points. Okay, so we have at least 2 minutes worth of data points for both graphs now, so both sensor data streams. And let's make this a little bit more interesting. Let's go run that benchmark again for 60 seconds, and I'll show you how this graph will update, and we'll see the rise in temperature. So the CPU and the server are not really high frequency CPUs, so you're not going to see a massive temperature spike. But you can see that from the mid 30s that it was in, now it's in the mid 40 range, on CPU 2, and very similarly on CPU 1. It was originally in the mid 30 Celsius, and now it is in the mid 40s and rising. So, and the last value here is 44 degrees. The max value observed so far is 44 degrees on CPU 1, and on CPU 2 the last value is at 47, so it's just getting closer to 50 degrees, and the benchmark stopped. So now you can see the temperatures are coming back down. And the nice thing about this program is that it also automatically resizes. So you know how earlier when I ran this manually I had to input the size? Well, this, every time it refreshes, it's going to automatically detect the size of your terminal. So let's say you want to look at a higher resolution of this ASCII art graph, and just maximize this, and you'll see that it automatically resizes the ASCII art to match your terminal size. So you can, if you have a really big screen, you could blow this up and look at a really large ASCII art graph of your data stream. Alright, and if you resize it, it'll go back down to a smaller size. Alright, so anyway, I hope that little script will be helpful to you guys. If you might enjoy using it if you're working on a server that has no proper graphical environment, and not let that stop you from actually visualizing your data in a command line environment. Alright, and oh, by the way, that program is meant to work with basically any sensor data that you can see in the sensors command. So we're monitoring temperatures here, but you could probably monitor the voltages, you can monitor fan speeds, you can visualize all of that in a command line environment with this script called sensor plotters, or sensors plotter. Okay, so anyway, hope you guys enjoy that. If you like this video, give me a like, and be sure to subscribe if you'd like to see more tips like these. Alright, thanks, bye bye.